Okay, so hopefully you got a chance to practice your naming of acids. And we have two types, binary and oxyacids. Binary acids contain only two elements. So if you have an acid that contains only two elements, one of them of course being hydrogen, that is a binary acid. If you have something that has a polyatomic ion, that is a oxyacid. And how do we know what our polyatomic ions are? I included this. Okay? So all you have to do is look them up. They're right there. Okay? No big heavy duty stuff going on here. So remember that when we have binary acids, these always have the hydro prefix. So anytime we have a binary acid, they're all going to start like this. Hydro this, hydro that, hydro blah, hydro. Okay? So we're all going to start the same way. All we need to be able to do is identify what they're paired up with, and we're going to change the ending to ic. So clearly, let's start with this first one. It's clearly chlorine, so we're going to say hydrochlor, and we're going to change the ending to ic. Clearly iodine, so we're going to simply change the ending to ic. Clearly sulfur, so we're going to change the ending to ic. Now there's a couple ways that you could do this one. Some of you are going to write hydrosulfic, and that's fine with me. But typically we stick ic on the ending of this one. Hydrosulfuric. Okay? Finally, this one is clearly fluorine, but we're going to change it to ic. Okay? Easy peasy. All right. Please write formulas for the following binary acids. Clearly, this is bromine we're talking about. H, and it always has a charge of +1. Bromine, right here. It always has a charge of -1. So we're going to do our droppage and swappage, and you don't need to use subscripts when it's 1. Okay? What the heck is that? A stantic acid? I don't think I listed it here. But if you look on your periodic table, which you all have, let's see if we can find one here. The periodic table. Let's go find one. Because you guys are probably looking for one too, right? So, periodic table. I like this first one that pops up. Periodictable.com. Boop. Okay, what's this magical symbol that we're talking about here for Istantai? That's not what I wanted. I don't like this periodic table. Let's go look for another one. This one doesn't do it for me. Sorry, everybody. Try this one. Actually, we could just use this one right here. There it is right there. right here. So here's our fluorine, chlorine, bromine, iodine, AT. That's our astatine. So that's going to be the one that we want. Okay. So you might want to add this onto your periodic table if you're feeling frisky. That astatine is in the same group as all these others, and that means that it has a charge of -1. So H plus and AT -1. Look at that. We do our drop and swap, and this is hat. How about that? That works out. All right, last one is hydronitric acid. Nitric looks like nitrogen, and we want to find out what charge nitrogen has. So here is our list. Here it is, nitrogen with a charge of -3. So let's put a -3 here, and we'll do our drop and swap. And that means we're going to need H3N. Okay, that takes care of our binary acids on this little tour. So let's try our oxy acids, and they include a polyatomic ion. We're also going to have this rule. I see you ate. Did you save a bite for us? Meaning anytime that you have a polyatomic ion that ends in -8, we're going to change it to -ic. Anytime you have one that ends in -ite, we're going to change it to -us. All right? Here's all this stuff right here, which kind of gives you an idea of how it works. All right? So what I like to do when I'm doing these, if I'm naming these, I like to keep this straight. That that 8 equals -ic and ite equals -us. All you got to do is look them up. So we're not worried about the H part. That's what makes it an acid. All we're worried about is the polyatomic ion part. So we're looking for this first one, ClO4, right here. It's polyatomic ion, ClO4. It's called perchlorate. Ends in 8. So if it ends in 8, we're going to change that perchlorate to perchloric. Remember that oxy acids don't use the hydro prefix, so we don't need this anymore. All we have to do is know what the ending of our polyatomic ion is. That makes this perchloric acid. So the same thing with this guy, NO2. Right here, NO2, we see it right here. And this is something called nitrite. So it ends ITE, and that means we're going to change it to -us. There is no hydro prefix, so if it is nitrite, we're going to change it to -us. Nitrous acid. Let's be careful because this next one, NO3, very similar. Looks like this, NO3, and that is nitrate. So really similar, but because it ends in 8, we're going to change it to -ic. This is nitric acid. And the last one, right here, CO3. We're looking for CO3 right up here at the top. It is called carbonate. Ends in 8. So I see you 8. We're going to change that to -ic, and we'll call that carbonic acid. Okay? Really easy. This last one is asking us to write formulas for some of these. All right. So we got sulfuric and sulfurous. That means it's a polyatomic ion that contains sulfur. Let's go hunting. And we see that there are these two polyatomic ions that contain sulfur. There is sulfate, SO4, and sulfite, SO3. So let's be careful. They both have a charge of -2. So what we're going to do is do our best to write the formulas for these, and they're going to contain hydrogen, which has a charge of +1. Sulfuric comes from sulfate, which has a charge of -2, and so we're going to do our drop and swap. We don't need a subscript when it's 1, so we just have 1 SO4. Same thing is true with sulfurous acid, but sulfurous ends in ite. Sulfite with a charge of -2. You just saw where I got those. We're going to do our drop and swap, and it looks like this. Oops, my eraser busted. SO3. Okay, getting the hang of it. Phosphoric. We're looking for a polyatomic ion that contains phosphorus, phosphorus, phosphorus. I feel like I'm shopping. Phosphorus. I don't see any phosphorus in there. No phosphorus. How about over here? I don't see any phosphorus in here. I see hydrogen phosphate, but that's not what we want. We want something that just has phosphorus in it. Boom! Phosphate. So it has a charge of -3. We're on the right track. So we have H plus, and phosphoric means it came from phosphate-ic because it ends in 8. It has a charge of -3. That means we're going to need to do our drop and swap. That means we're going to need 3 H's and 1 PO4. Last one, nitrous. Well, you could go look for it, or you could find it right here. Mr. L, that's cheating. No, it's not cheating. It's using your resources. If you didn't want to do it that way, you wanted to do it the honest way, you're looking for a polyatomic ion that contains nitrogen and ends in ite. Polyatomic ion that contains nitrogen and ends in ite. Right there. It's got a charge of -1. So if we're doing this the honest way, H plus NO2 has got a charge of -1. You don't need a subscript when there's a charge of 1. Okay? That's how you do it. All right? We're going to practice this some more, but that's how you do this first set. Okay?